is lasers, second one is fiber optics. Okay, first part laser we will start. And this in the lasers we have ruby laser, that is solid state lasers. First we will discuss introduction about how the lasers will work, what materials are there, what are there. Okay, after that different types of lasers are there. In solid state laser we will study about ruby laser. There are different type of lasers, but in the syllabus we have only ruby laser. In the gas lasers we have helium neon laser. Okay, liquid lasers, semiconductor lasers. This semiconductor lasers also we will discuss this one also. And examiner lasers, this is not in syllabus. Only we have three types of lasers in the syllabus. One is ruby laser, that is solid state laser. And gas lasers, in gas lasers only we have helium neon laser. And third one, semiconductor lasers. In that we have homojunction and heterojunction. How these lasers are classified means depending on material. Okay, if you use the solid material, that is solid state laser. Okay, if you use gas molecules or gas atom, then that is gas lasers. If you use semiconductor materials to create laser beam, there you will use the semiconductor lasers. Okay, these are different types of lasers. Okay, first in laser abbreviation means, what is laser abbreviation? Already you know this one. Light amplification by stimulated emission of radiation. Okay, here what we are doing, we are amplifying the light. Okay, first we are creating the light. Light means just nothing but photons only. We are creating the light. And how we are creating this light? By stimulated emission process. Okay, stimulated emission process. Okay, by this stimulated emission of radiation or light, you can say. Okay, this radiation we are using stimulated emission process. And these whatever emitted photons or whatever emitted light, we are amplifying. Amplification or amplifying means we are strengthening the light. Okay, we are strengthening the light, that is laser beam. Okay, so
Sir, what is meant by ND and AS, sir? Previous slide.
yeah, nd, neodymium, that is one second. That is neobium, I guess neobium, yttrium, and A for something is there. I exactly don't know. This is also materials, different materials. Okay,
Okay, sir.
I will tell you tomorrow. Abbreviation I forgot this A and G. I will tell you tomorrow. Okay,
Okay, sir.
and these are different elements. Different elements, they used as a single material and compound, just like a compound, and they use it for creating the laser beam. That is okay. I will tell you full abbreviation what is the atoms. Okay, tomorrow. So here is the uh, uh, amplified light. We are getting the laser beam. That is what laser beam, high intensity light. That is okay. So in 1917, first in 1917, this Albert Einstein put the foundation for laser beam. Okay, what he did when light, okay, when light interact with matter. Okay, light interaction of matter. Okay, when light interact with matter, what happens? Okay, what happens, what is the process, what process are there, what type of things will takes place there. Okay, that he proposed, that we will discuss in today class only. Okay, this is the main foundation for producing the laser beam. Okay, light interaction of matter. Okay, and in 1958, what this ch Cones, theoretical, and this guy other person also, they developed theoretically laser beam. What is the laser beam, how we can create using different materials? Theoretically they proved it. Okay, but theoretically developed, or you can say. Then after that, in 1960, the Mayman first he developed the ruby laser. Okay, first laser was ruby laser, that is solid state laser. Okay, in this solid state laser they used the ruby crystal. This is crystal, some crystal. Ruby means some crystal. It is a aluminum oxide and chromium ions. Okay, this combination of these two we are calling a ruby crystal. Okay, using this ruby crystal, they have developed a laser and produced a laser beam. That is the first laser. It is solid state laser. Okay. After that, many lasers are came one by one. They developed one by one. Okay. So gas lasers and liquid lasers, semiconductor lasers, after that only one by one they developed it. Okay, so why we are before going to learn the subject, why, what are the application, why we are this much interested to learn this lasers? Okay, first point, we have to see applications and advantages, how easily we can produce the laser beam. This depends. Okay, so if you have lots of application, you can develop many things. Okay, so we'll see here laser applications. In laser application, many industries we can use this lasers like a cleaning, okay, cleaning purpose or welding purpose. And suppose you want to cut the hard surfaces, or suppose you want to, there is any piece, okay, any solid hard piece or any jewelries. Okay, if you have jewelry, so you want to carve it in a very required shape, like a without damaging or without creating any breaks or strain or stress in the material. You want to cut very sharply, you can use the laser and you can carve it your required dimension, required structure. Okay, and also ablation means what here? Ablation means you want to eject some atoms from a material. Suppose you are incident on a material, and from there you can eject some atoms here. Okay, this is what ablation means. Okay, and drilling and this many things. Okay, in medical also you can use in every hospital nowadays they are writing laser treatment. Okay, every day we are mostly seeing on boards of the hospital boards, we are seeing laser treatment. Okay, so they will send the laser beam, and without operation they can do many surgeries and things. Okay, and dentistry and medical and 3D printing. Okay, and electronics also, mobiles and laptops and TVs, many aeronautics also, aeroplanes and sensors, automobiles, meteorology, using some meteorology also, using lasers also you can say predict the when you will get the rainfall, when you will get sunlight, what is the sunlight temperature, like that you can see. And also you can using data storage and communication systems and displays, spectroscopy and energy technologies, military applications. Suppose you are wearing a military defense in the defense, you are to target the object, you can use the lasers and you can focus on a object, and this laser will incident here. After that, it will reflect back, and you will identify clear focusing, and you can drop the bomb like that. In defense also, you can use these lasers. And also in many science and technology, many science concepts and technology also, you can use this lasers. Okay, so this laser is having many advantages, many applications. That's why we are very much interested in this thing. And also if you go shopping also, they always scan this barcode. Okay, so scanning barcode, if you want to enter manually how much items you have purchased, and what is the price and what is the details of the item, it will take huge time. So to save the time, and you can just scan it. Okay, then its work is done within 1 second, 2 second, like that. Okay, to simplify the things, here laser is many places are using. Okay, if you want to make surgery also, you have to take huge time and risk also. If you send laser and get surgery and without any damage and anything, that is very good, right? So that's why we are using in laser many applications. That's why we are very much interested in laser. So how this will work, what type of lasers are there, what type of applications we can use, this we will learn in this topic. Okay, so laser, first we will see the laser properties. Okay, compared to normal light, laser have some different properties. Okay, that we will see. Okay, already you know laser, when you already you know these properties, but we will go through it. Okay, this is highly monochromatic. Laser beam is highly monochromatic. That means it is having a only, it will produce, or it is containing only one light or one wavelength. Okay, that is what monochromatic. Mono means what? Single. Chromatic means color. Okay, this is just monochromatic means color, and mono means single. Mono, one color is always having, suppose yellow, if you take yellow, it is having only about 430 nanometer color only. Okay, if you take red, it is about 650 nanometer. Okay, one color only having only one wavelength. That's why it will produce only one wavelength only. It is monochromatic. That's why we are calling highly monochromatic and also highly coherent. Okay, that means what? Suppose if you have a laser beam here, laser light is coming. This light is are in same phase. Okay, the phase of the light is same. Or you can say if you see observe this one, you feel light is coming from only one point source. Okay, only one point source this light is coming, you can see that way, then it is called as a coherent source or coherent light. Okay, that is one more thing. And polarized light, this is highly polarized. So suppose in generally light can propagate in x y z direction, suppose x y z direction, but this is unpolarized light. Okay, the light whatever we are discussing, so this can propagate in S direction or Y direction or Z direction. So but laser only it will propagate one direction only, unidirectional or one direction. It will not spread into different direction. Suppose this is unpolarized light, that means it is propagating in all x, y, z direction. Suppose if you keep a slit along y direction, this is along y direction, only after propagating this light through the slit, okay, it will only allows y components, it will block the x and y, x and z component. It is polarized light. Okay, polarized. So the unpolarized means light can propagate three directions. Okay, polarized means light can only propagate any one direction. Okay, that is mean polarization means if you see normal light that will spread into all directions, right? So this is the, and also here one more thing is intensity also very high. Okay, intensity. So if you see in movies also you will see laser barriers. Okay, laser protection also they will keep. So if you touch that laser beam, your hand will cut immediately, hand or something, it will cut. So because high intensity, this is having very high intensity. Because why this is having high intensity? Because of in same phase, all light whatever light is in same phase, if these are in same phase, there is a constructive interference. That means intensity will higher. Okay, intensity will higher at the center. Or you can say if light is in same phase or in same one phase, or you can say coherence, the light intensity will increase. Okay, because of constructive interference the light intensity will increase. That's why laser beam always having high intensity. Okay, is this clear? These properties, these five are very important properties to distinguish the normal light and laser light. Okay, is this properties clear to you guys?
Yes, sir.
So after, okay, thank you. And after that, okay, after that next we will see, if you see in our homes also we will observe this light, general LED lamp or incandescent lamp we have. Okay, and if you compare these two light in laser, this will light will produced by stimulated emission, whereas in normal bulbs or LEDs, this is by spontaneous emission process. So we will discuss what is the spontaneous, what is the stimulated emission process. We will discuss it. Okay, and here in laser it is a monochromatic light. Here it is a polychromatic. Polychromatic means many wavelength will be involved in this light. So generally in our homes we will have a white lamps, right? White bulb. It is white light means it is contain all wavelengths like a VIBGR. Vib, VIBGR, VIBGR, you know, right? So all lights, and also in I energy also I intensity or energy also very high for laser, but in our light the energy is very less. So that's why only we are freely able to sit the under lamp. Okay, otherwise if intensity very high we cannot sit under the light, right? So here also it is parallelism, or you can say coherence, and also it is here it will divergence is very high. In normal light it will propagate in all directions, right? All direction, then only one light is enough to lamp the whole room. Okay, it will cover whole room to light them. Okay, and also it is we can easily focus, but here it cannot focus because it is spreading throughout the all direction, but laser is only focus beam. You can focus anywhere where you want to focus. You can focus it and you can use it, this laser. Okay, these are the differences between normal light and laser light. Okay, so here we will see what in 1916 what Einstein proposed. Okay, so this is